Hello, it's Mr. Cerisa, and this time we'll talk about performing operations with vectors in space, finding the distance, finding the position vector, finding the unit vectors, and you'll find out that these are very similar to what you've done before. The only difference is now there is this new z coordinate, or k vector. So let's first go over the distance formula. Again, if you just focus on this part of it, that's the old distance formula. And now you have the z component, and that's all it is. You're just adding in another difference squared. So let's go through an example. In this case, we're finding the distance from P1 to P2. So what I need to do is find the differences between P1, which is 2, -1, 4, and P2. So if I subtract these, -3 minus 2, 5 minus -1, and -1 minus 4. I have that, so my distance formula will look like this. And so I did all this stuff on the side so that I can do it quickly, but I am showing you each of the steps. And I'm okay if you show me, you should show first the distance formula, but then you go to the 25, 36, and 25. Don't just jump to the square root of 86 though. I want to see where you got those numbers. So somehow show me a few of these steps as you go through. But there it is, square root of 86, and if you wanted to, or if you needed to, in an application problem, give a rounded answer, a decimal answer to the tenths place, then you would do that. But normally, you would just leave it in exact terms like I did. Alright, next we'd find the position vector, and you can see here again with the graph, you have the x, y, and z, but we have this position vector going right here to ABC, some point ABC. So we have A amount of the I vector, and we have B amount of the J vector, and then C amount of this K vector. And these are all unit vectors, so they're just how many units are they going out. So we can decompose them in these three different vectors, and just like you did two different vectors before. So here's the official equation. Again, you had the first part of it, and now we're just adding on this z part of it. So it really should feel very familiar to you at this point. So let's go through an example, and we're looking for this position vector, and we know it's starting with P1 and going to P2. So I'm going to copy over this P1 underneath and subtract. So I'm subtracting all of this, so 1 minus 2, and then 4 minus -1, and then 2 minus 4 is -2. And so that's what it looks like if we're putting it in the vector form, but they probably want it in this form with the decomposition. So -I plus 5j minus 2k. And there it is in that form. Next we'll have different operations, so you can pause this and copy these down if you like, but they're again very similar to what we did before. If you're adding the vectors, you're adding those coefficients for each I, j, and k. Subtracting, you subtract. Scalar multiplication, you just multiply each of them. It's like distribution. And then you have the magnitude, which is just like finding the radius or using the distance formula. And so on this, if we're adding, I'm just going to do the adding one and then the subtracting one. So if you want to pause this, try it on your own, and then check your answers. Go ahead. Okay, and here are the answers for that. So go ahead, check your results, and if you did not get the right answer, then check why. Alright, and then scalar multiplication. This is very familiar as well. And so pause it now, and then I'll give you the answer in a second. Okay, go ahead and check your answers. And then we're going to go on to the unit vector, and you can see this is exactly what we had before. The unit vector is just the vector divided by the magnitude. So if you can find the magnitude, now you're just dividing it by the I, j, and k vector. And then for that vector, just another way to put it is the vector is equal to the magnitude times the unit. Alright, so here we have an example, and we find the unit vector in the same direction as this one. So first thing that we have to do is find out what the magnitude is. So I'm going to walk you through this one, not like the other ones. I'll walk you through, and so the magnitude of v is just going to be the square root of the negative 2 squared plus 4 squared plus 3 squared. And so of course that's the square root of 4 plus 16 plus 9, so square root of 29. Alright, and then we find out which direction it's going in, so we need, or sorry, we're finding the unit vector, so we're dividing this whole vector by the magnitude. And so we have negative 2i, now we're dividing that by a square root of 29. And we have 4j, we divide it by a square root of 29. And then k, we have 3k, divided by the square root of 29. And then there you go, so that v now becomes the u, because we took the v and divided it by the magnitude. Okay, so there's the unit vector. Alright, so thank you very much, and then we'll finish up with these unit vectors in 1 second.